Welcome. In this particular demo, we're going to have a look at playback of sound within our game, either streaming a particular music clip or playing back a sound effect within our game. So two different aspects. If you listen to the associated lecture of this, you'll know that sound is actually quite an important component by way of increasing the believability of our game. So it is something that we do want to put within. So we'll have a look at two things. We'll look first of all at the use of a sound pull. This is set up so whenever I tap the screen you'll hear an explosion sound. And the frequency with which I tap it determines how often the sound is played. So they're sound effects. They're sounds that I trigger based on some event, and they generally are fire and forget. I trigger the playback of it, it plays, it finishes fairly shortly thereafter. The other thing we want to look at is actually playing a longer piece of music. This, for example, could be background music that we may want to continuously play and to loop around. So I have a short clip here.
Hello? Anyone out there? Hello? Anyone out there? Hello? Anyone out there?
And it will carry on forever after, as enjoyable as that is. So there, if we do have background music, we can play that background music and using whatever sort of clip we want to put in. So two different types of sound playback we want to look at. We'll start off first of all having a look at the sound effects, which we will manage through a sound pull. Now, a sound pull, it's a fairly, the name sort of gives it away. It is a collection of sounds, a pool of sounds, and these are sounds that have been loaded into memory. So we populate our sound pool with different sound effects that we have loaded in. And the sound pool, it manages the playback of these different sound effects. And you'll see here when we're creating it, we give it a maximum number of channels. So we say that what is the maximum number of simultaneous sounds that pool can play back. So we can have a maximum in terms of the demo of 20 simultaneous sounds being triggered by clicking on the particular surface. If you have more than 20, how does it do it? Whenever you add a sound clip in, you give it priority. And it uses that along with, well, which ones have been playing the longest to decide which ones to discard. So low priority or things that have been playing for a long time, they're the ones you kick out to make way for your new incoming sounds if need be. We're also going to have some way of referring to or identifying our particular sound clips so that we can go to the sound pool and we can request that a particular clip is played back from it. We do this using an integer reference to the sound. So whenever we load it in, we'll get an int reference, and we can then use that by way of triggering playback of it. Here we're just setting a value of -1 to signify that the ID isn't yet available. It'll be a positive number that we'll get when it is available. By way then of having a look, we've got our on view. We're just simply creating that simple view. We're setting up a text view. And we're adding in a click listener. So this is the bit that will that will trigger playback of the particular sound. So when we have a click, we want to check to see have we loaded in our sound effect yet. So just in case it hasn't been loaded in, we'll not trigger the playback. If it has been, then this line here, which is actually quite a capable line, is all that you need to commence playback of that sound clip. We go to the sound pool, and we say, we want you to play one of the clips that you store within you, and this is the ID of the clip. Remember, we're going to get that when we load it in. And then we have a bunch of parameters that follow after it. Now these parameters, the first two is the left channel volume and the right channel volume. So if we want it to play the clip sort of a lower volume, or to have it so that it moves from the left to the right channel, we can vary the playback of it here depending on the channel volume. The one after that then is the priority that we give to that particular clip, and that's only really used if all of our channel sounds are being used, and the sound pool has to work out which one does it stop. It'll use the priority. After that, we then have the loop values. This is the number of times we want it to loop. This can be slightly confusing. If I specify a value of -1, it means loop indefinitely. So keep on playing it, looping around until you're asked to stop. If I specify a value of 0, it means play it once. If I specify a value of 1, so a loop value means loop it an additional 1 time. So a loop value of 1 will play the clip once and then loop it for 1 additional time. If I want it to play the clip a total of 10 times, then my loop value would be 9. So I play it once and then an additional 9 loops thereafter. The final property, this is the rate with which we play it back. So a value of 1 means at normal playback rate. If I have a value of greater than 1 or less than 1, then it either plays back faster or slower. Now it is range, so I think that the recommended values is between a value of 0.5 up till 2. So you can play it back 50% slower or play it back 100% faster. So you get quite a lot of control over how the sound clip gets to be played. When we're down here, we've got set volume control stream. So this is an important bit. So we are playing sounds here. We're playing sounds through an activity, and for an activity, you can request that the activity acknowledges or takes notice if the user changes the volume on their device. So most devices will have a volume control. It could be a hardware button or a rocker on it, and if you want to have the activity set up so that if the user is changing things there, then you can filter those things through to the activity, and it's a good thing to do. Okay, so this was within the on-click listener, is the activities that happen every time we click on it. This is still part of the setup. So as part of our setup, we've defined our action listener, we've set up the volume control. Finally, as part of the setup, we are creating the actual sound pool that we want to use. Now this is perfectly fine for up till Android 4.4 to KitKat. The most recent version that's been released, Android 5, in terms of recording this, has just been released. It actually has changed this, so there's actually a different way of using a sound pool builder by way of creating it. And there it actually offers arguably a better way of managing this, because you can ask that we have a sound pool created that is suitable for gaming. In this particular case, we're creating the sound pool, we're given maximum number of channels, and we're saying how we want to create it. So stream music is probably the most appropriate one that we have there. But as mentioned, on Android 5 we do actually have an opportunity of setting up for a game. We, having created the sound pool, need to populate the sound pool with something to give it some content. So we're using our asset manager to give us a asset file descriptor. So this is to the particular explosion effect in this case that we are loading in. So we don't get simply an input stream to it. We get an asset file descriptor that tends to be used by the sound classes. And we go to our sound pool and we say, can you load in whatever is described in terms of that particular asset. The value then at the end is the default priority that we give to it. Currently has no effect, I believe, in terms of the APIs, and actually just recommend you should put a value of 1 for future compatibility, so it's a bit of a red herring. When we load it in, it's going to give us an explosion ID. This is the ID that we can use to refer to that particular clip within the sound pool. We try to load it in because we may not be successful in loading the file. We catch any errors if we do have a problem. And down here we're at the bottom of configuring our view, even though our view actually loaded in some sound clips. Probably shouldn't have done that, should have done it on create as opposed to on create view, but nonetheless, for reasons of simplicity, we have it here. The bit at the end is important, that you want to make sure that you release the sound pool, release the sounds that you've loaded in when you're finished. So whenever we destroy this particular fragment, which is when the activity gets to be destroyed, we're going to make sure that we release all of the clips that we have within the sound pool, and that's tidying up after ourselves. So fairly simple, fairly straightforward for that. Next one we'll have a look at is the media player. So this is the one we use for streaming the background music as opposed to triggering the playback of the odd clip. To do that, we're using a media player. Now, a media player is a very capable object that's available within Android. It's used to control the playback of audio, as we're using here, also video. So you can use it for quite a wide range. There is it comes along with a fairly complex state diagram in terms of when you start your audio, or whatever it is, audio or video, but going into, well, actually it's idle, to be initialized, to preparing to be able to play it, to be able to start to play it. And when you are starting, you can pause it, you can stop it, and you can rotate around these. So it has its own life cycle, not entirely dissimilar to some of the states you would find within the activity or the fragment. So we're using a media player. We've got a flag that's going to tell us if the media is available to be played. Because we're loading this in this case here from a disk file, we just want to make sure that we have it available before we request and start trying to play it back. Same thing as before, we're actually doing all of this in the onCreate view. We're inflating a view. We're setting up here the volume control so that we control that as well. There's no, as soon as we go into this view, we're going to come into playback. So it happens as soon as this fragment starts up. And this is a bit here that does all of that work. So we're creating a new media player. And we're going to try to do the following. Now, we're going to try. It may not work. It involves loading in files from a disk. So if it doesn't work, we will flag up that there has been an error in doing so. We're using our asset manager. As with the previous one, we're using asset file descriptors. So they're packaging up more information than just simply an input stream. In particular, we'll look down here in a second. We're then going to our media player, and we're saying this is your data source. So the media player takes a data source. It's where it gets its information from in terms of doing the playback. And we've got to pass in a few bits of information about the source of the media players, in this case audio. So we go to our file descriptor. We can get the actual file on disk. We can also work out where is the start offset within that file and how long is that file. And that's all of the information that the media player needs to get it going. We set the media player looping to be true, so whenever it's finished streaming files from this here, it's going to repeat the process and keep on doing that. And then finally we call our prepare method. Prepare is the one that actually gets it ready for playback. So we're asking it, okay, there's a file, can you do whatever setup is needed so that you can actually commence playback of it. Now, there's actually two different versions. You've got a prepare method, and you also have a prepare async method. The prepare, this version here, is run synchronously, and the prepare async is run asynchronously. If I'm trying to load in a piece of audio that is packaged up in this app, so it's available with it, then prepare is perfectly fine. That's the thing that you should call. It blocks until the clip is ready to play, so it's going to stop at this point until it actually is ready to play. As long as I have it available on disk, it shouldn't take too long for this to happen. If, however, the media that I was trying to play, if it was a video that I maybe was streaming from an external site, it could take me maybe a second or whatever to connect to that site, to link to the video, to start pulling it across the network connection. That's a fairly long period of time, so the other version is the prepare async, and whenever that's called, it returns immediately, so it passes control back immediately. It's designed really to work for environments where you want to get on with things, and then whenever you have enough content streamed across to commence playback, you can commence playback at that particular point. Not an issue for us because we're packaging our sound up along with our application here. Down at this point, because we have called prepare, we know that when it finishes blocking, we are ready to go. We can set, yes, the media is available. It is available to commence playback. If this is the async version, we couldn't immediately jump to that conclusion. We'd have to check to see is enough loaded in. Now, this is the setup. The setup basically prepared the media for playback. Where do we play it back? We're doing this on the resume, and we're going to stop it on the on pause button. So as we go to that fragment or leave that fragment, we will resume or pause the playback of it. So when we resume it, we just double check to make sure, yes, it should be available, and then we start the media player. It starts playback. When we pause, we get a few checks here that we're going to initially pause the media player, but we're further doing a final check here. I mean, we could have put this on destroy if we wanted to, but we're putting it here. So we're also checking to see, right, we've paused, but are we pausing as one step towards destroying this particular fragment? Have we finished? So if the actual activity is in the process of finishing as well, then we don't simply pause, we stop the playback and we release the clip as well. So we clean up after ourselves. And that's it. It's a fairly straightforward piece of code for both using the sound pull and using the media player, and that is all that we need by way of managing the type of audio playback that we will almost certainly have within our games.